Hey guys, tonight, we're going to imagine something truly incredible. Something that twists the very fabric of our reality into a shape almost unrecognizable. Close your eyes for a moment and picture the Earth as you know it. The gentle curves of its continents, the sprawling oceans, the delicate thin veil of its atmosphere. It's a world, you know, a world you've walked, a world you feel an intrinsic connection to. Now, let's discard that image. Let's imagine a different Earth, an Earth so vast it defies comprehension. We're going to explore a world where our tiny blue marble has swelled to the size of the sun itself. And a small gentle warning, you probably wouldn't survive this journey. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, I'd love to know where you are right now and what time it is for you. As you settle in, let's begin our quiet descent into this new reality, a place where the familiar is swallowed by the monumental. The first most immediate and perhaps most terrifying consequence of this cosmic expansion would be the sheer unyielding force of gravity. Our current Earth, with its cozy 5.972 x 10e member 24 kilo mass, holds us in a familiar embrace. We are comfortable with the pull, the weight of our own bodies, the effort it takes to walk or to jump. This is all a product of its mass. The sun, however, is a different beast entirely. It weighs roughly 333,000 times more than Earth. If our planet were to suddenly instantaneously balloon to that size, its mass would become unimaginable. A person weighing 150 pounds on the surface of our current Earth would suddenly find themselves weighed down by over 45,000 pounds. It wouldn't be a gentle increase. It would be an immediate crushing blow. The very atoms that make up your body would feel an unprecedented pull, a force so strong it would likely compress you into a dense, unrecognizable smear on the newly expanded surface. Buildings, mountains, and even entire continents would buckle under their own newfound weight, their structures failing in an instant. This is not a slow, gentle transition, but a cataclysm of physics. This incredible gravitational force, this new planetary constant, would be the primary sculptor of our new world. Everything and I mean everything, would be subject to its tyrannical rule. The atmosphere, once a fragile and dynamic layer, would be crushed into a dense, suffocating blanket. The air we breathe today, a gentle mixture of nitrogen and oxygen, would become a heavy viscous fluid. The pressure at the surface would be immense, rivaling the depths of our current oceans. This isn't just about breathing. It's about the fundamental properties of matter. Gases under such pressure would behave more like liquids, their molecules packed so tightly together that they would lose their characteristic freedom. This would create a hazy, shimmering atmosphere, perhaps a perpetually twilight-like sky, where light struggles to penetrate the dense layers above. It's a fundamental change to the very nature of existence. We understand this on a smaller scale, of course. Think of a deep-sea diver feeling the weight of the water above them. Now amplify that feeling to an unimaginable degree, not from water, but from the very air itself. This leads to one of the most fascinating questions in physics. What happens to the boundaries of matter when pressure becomes the dominant force? When is gas no longer a gas? And what is the next state of matter beyond that? The geology of this new Earth would also undergo a violent transformation. Our current planet has a dynamic churning mantle of molten rock, a process we call plate tectonics. This engine, driven by the heat of the core, is what gives us volcanoes, earthquakes, and the slow, majestic drift of our continents. But a super-Earth with the mass of the sun would have a different kind of inner engine. The sheer gravitational pressure would create a core of unimaginable density and heat. The familiar layers of crust, mantle, and core would be compressed and rearranged. Some scientists believe that on such a massive planet, the mantle would become so viscous and hot that plate tectonics might cease altogether, frozen in place by the immense weight. Others argue the opposite, suggesting that the pressure could trigger supervolcanoes and earthquakes on a scale we cannot even begin to comprehend, making our current planet's geological activity seem like a gentle whisper in comparison. The truth is, we don't really know for sure what happens to the geological engine of a planet when it is scaled up so dramatically. It's a mystery wrapped in the heavy cloak of gravity. As we ponder this immense transformation, it's worth thinking about the very structure of the Earth itself. Our familiar planet is a sphere, but a super-Earth might not retain that perfect shape. The immense gravity would pull everything toward the center with such force that any imperfections, any mountains or valleys, would be smoothed out over time. The planet would become an almost perfect featureless sphere. This is a scientific fact related to something called hydrostatic equilibrium. Any body with enough mass will pull itself into a spherical shape. The Sun is a perfect example of this, a near-perfect sphere, because of its immense gravitational pull. Our new Earth would be no different. The crags of the Himalayas, the vast valleys of the Grand Canyon, all the familiar imperfections of our home would be erased, flattened by the relentless pull of gravity. It's a powerful, humbling thought. The very forces that define our world are also capable of erasing its most distinguishing features. The paradox is that the very strength that creates mountains is the same strength that in its extreme would unmake them. This tension between creation and destruction, a familiar theme in both science and philosophy, would be etched into the very surface of this new, gargantuan world. It makes you wonder, doesn't it, about the delicate balance of forces that allow for the richness of our current world. The truth is, our little Earth is a masterpiece of just the right forces, and to change any one of them so drastically is to create a masterpiece of a different and far more terrifying kind. This newly formed giant would not simply sit silently in space. Its immense gravitational presence would ripple outward, affecting everything in its path. Remember how we often talk about the delicate, almost choreographed dance of the planets in our solar system? The intricate balance of orbits, the gravitational tugs and pulls that keep everything in its place, all of that would be thrown into immediate and utter chaos. The Moon, our steadfast companion, would be the first to feel the brunt of this change. Its orbit would become unstable, spiraling inward until it was either torn apart by the new Earth's tidal forces, or it would crash into the surface with unimaginable force. The result would be a final cataclysmic display, a moment of cosmic violence that would shatter the celestial ballet we have grown so accustomed to. This is a scientific principle known as the Roche limit. The distance within which a celestial body held together by its own gravity will disintegrate due to the tidal forces of a larger celestial body. Our Moon would cross that line, and in a shower of debris, it would cease to be. The other planets, too, would not be immune. Mercury and Venus would be pulled into highly erratic orbits, perhaps eventually flung out of the solar system entirely, or drawn into a fiery collision with our new massive world. Even the gas giants, Jupiter and Saturn, would feel the new gravitational influence. The intricate celestial mechanics that govern their paths would be rewritten. Our solar system would no longer be a series of predictable ellipses, but a chaotic pinball machine. The sheer power of this new Earth would dominate the Sun's gravitational influence in our local cosmic neighborhood. This reordering of the cosmos reminds us of a core tenet of planetary science. Gravity is the great orchestrator of the universe, and its slightest change can unravel a symphony of stars and worlds. It also introduces a curious philosophical point. If the familiar order of the cosmos is so easily disrupted, what does that say about the permanence of anything? The planets we see in the night sky, stable and unchanging for millennia, are in fact a temporary, fragile arrangement. As we consider the scale of this change, let's step back and consider the strange paradox of gravitational time dilation. This is a core concept from Einstein's theory of relativity. It tells us that time itself is not a universal constant. but is influenced by gravity. The stronger the gravity, the slower time moves. For someone standing on the surface of this new super-Earth, time would literally tick by slower than it would for someone in a spaceship far above the planet, or even for someone on our original Earth. It's not science fiction. It's a proven fact. While the effect is minuscule on our current planet, it would be profound on a world with the mass of the sun. A minute on the surface might be a minute and a half for someone far away. This would create a bizarre, almost surreal reality where time is a local phenomenon, a river flowing at different speeds depending on your location. The very concept of a shared now would cease to exist. This phenomenon raises a fascinating and as yet unanswered question. What would it be like to live in a world where your own personal experience of time is different from everyone else's? What would that do to our understanding of shared history of memory and of the future? The light from our sun, and indeed the light from the stars, would also behave differently. On our current Earth, starlight travels through a relatively thin atmosphere, creating the brilliant pinpricks of light we see at night. On a super-Earth with a dense, crushing atmosphere, this starlight would have a much more difficult journey. It would be bent and refracted, its path distorted. The sky itself might appear much hazier, with stars perhaps appearing less like points of light and more like faint, shimmering smudges. In fact, due to the phenomenon of gravitational lensing, the immense gravity of the planet would actually bend the light from distant objects, causing them to appear in strange, distorted patterns. It would be like looking at the universe through a cosmic funhouse mirror. The constellations we know and love, Orion the Big Dipper, would likely be unrecognizable. Their stars shifted and stretched in the sky. This change would not only be a visual spectacle, it would also be a fundamental challenge to the very foundation of astronomy. Our understanding of the universe based on the light we receive would have to be completely re-evaluated. It's a reminder that our view of the cosmos is not a direct window, but a reflection filtered through the forces of our own world. And what of the sun itself, the star that gives us life? Would it remain the same, a constant golden orb in our sky? The answer is likely no. The sun and Earth are in a gravitational dance, a relationship of equals even with their vastly different sizes. If one partner suddenly became so much larger, the dance would change. The sun would be pulled more forcefully, its own orbit slightly affected. More importantly, this immense new gravity might pull more material from the sun, or it might create massive, unprecedented solar flares. The intricate balance of forces that keeps the sun's fusion burning steadily would be tested. There's a curious scientific principle, the Novikov self-consistency principle, which suggests that anything that would cause a paradox in time travel cannot happen. While we aren't time traveling here, the principle's core idea is that the universe is inherently self-correcting. Would the universe correct this imbalance, or would it simply allow the chaos to unfold? This is one of those deeper questions that science can't answer, a question that dips its toes into the waters of philosophy. It's a quiet whisper in the background of all our scientific exploration. Are there limits to what can happen even in a cosmos so vast and strange? This thought experiment, as we see, isn't just about a change in size. It's about a change in every single fundamental rule of our existence. It's about the transformation of a world we call home into a world that is in every conceivable way an alien landscape. The ground beneath our feet, the air in our lungs, the light in our eyes, and even the relentless march of time would all be redefined. And as we continue this journey, we'll see how this single monumental change sets off a chain reaction that transforms our very understanding of life, of matter, and of the silent, powerful forces that shape everything around us. This is just the beginning of our exploration, a slow, gentle drift into the heart of a cosmic mystery. As we settle into this new profound gravity, the ripples of our planet's expansion begin to reach out beyond its immediate surface. We talked about the first terrifying consequences, the crushing pressure, the obliterated landscapes. But now, Let's lift our gaze from the surface and watch the cosmic dance unfold. The most significant player in this new drama, besides our monstrous Earth, would be our closest celestial neighbor, the Moon. For billions of years, the Moon has been our quiet companion, a gentle tug on our oceans, a constant presence in our night sky. Now, with the Earth's mass multiplied by over $300,000, that gentle tug would become a monstrous, irresistible pull. The Moon's fate would be sealed almost instantly. In the face of this immense new gravity, its stable orbit would begin to decay rapidly. We could imagine it as a slow cosmic death spiral, but in truth, it would be a relatively swift and violent affair. The Moon would be pulled closer and closer, its familiar spherical shape starting to distort under the immense tidal forces. Think of a baker kneading dough, stretching it, and pulling it into a long, thin shape. That's what our new Earth's gravity would do to the Moon. It would become ovoid, then elongated, until it reached a critical distance, the Roche limit we touched upon earlier. At this point, the tidal forces would become stronger than the Moon's own gravity, and it would simply be torn apart. Its surface would fracture, its core would be exposed, and a vast glowing ring of debris would form around our new super-Earth. This ring would be unlike Saturn's, not made of gentle ice particles, but of molten rock metal and shattered remnants of what was once our constant lunar companion. This celestial catastrophe reminds us of the profound truth that our universe is a place of immense power and fragility. The things we see as eternal, like the Moon in our sky, are only held together by a delicate balance of forces. Change one variable, and the masterpiece shatters. This new massive Earth wouldn't just be a passive object in the cosmos. It would be a dominant gravitational force, a new sun of sorts in our solar system's local neighborhood. The delicate ballet of the planets, a dance that has played out for over 4 billion years, would be thrown into immediate and utter chaos. Our inner planets, Mercury, Venus, Mars, would feel a gravitational pull so strong it would fundamentally alter their orbits. It's possible that Mercury, the closest planet to our original sun, would be pulled out of its stable path, flinging it either into the sun itself or on a new, highly eccentric orbit that could eventually send it hurtling into our giant new world. Venus, our twin, might share a similar fate. Its stable, nearly perfect circular orbit would be warped and stretched, turning its gentle path into a wild, unpredictable trajectory. Even the outer planets, the gas giants we see as untouchable, would be affected. Jupiter, the king of our solar system with its immense mass, would find itself in a new tug-of-war. The sun would still be the primary force, of course, but our new Earth would be a powerful contender, pulling at Jupiter and its moons with a force that would make the previous gravitational influences seem like a whisper. This change would introduce a scientific concept called n-body problem. It's a notoriously difficult problem in physics, where you try to predict the movements of 3 or more celestial bodies interacting with each other through gravity. With our new massive Earth, the elegant two-body problems of our current solar system would become impossibly complex n-body problems with new unpredictable outcomes. The old familiar clockwork of the solar system would be gone forever. The immense gravity of this new planet would also have a profound effect on the sun itself. Our sun is a star of immense power, but it is also a delicate balance of forces. Its outward pressure from nuclear fusion is perfectly counteracted by the inward pull of its own gravity. The planets in their orbits exert a tiny, almost negligible pull on the sun, but our new super-Earth, with the mass of the sun itself, would change that. The two bodies would find themselves in a new, strange, and highly unstable relationship. They would likely orbit a central point of gravity that exists somewhere between them. This could create immense gravitational stresses on the sun, possibly triggering more frequent and powerful solar flares, or even affecting its internal fusion processes. The very star that gives us life might find its own existence threatened by its new massive dance partner. We don't know for sure, of course. The interactions of two such immense equal mass objects at a planetary distance is a scenario that has never been observed. It's one of those beautiful unanswered questions that reminds us that science is a journey into the unknown. We can predict, we can model, but the truth is, we don't really know for sure. This immense gravitational field would also affect the very fabric of space-time around our new planet. Remember how we talked about gravitational time dilation in the previous part? This effect would not only be a local phenomenon on the surface of our super-Earth, but it would also warp space-time in its local neighborhood. An observer far away would notice that time is flowing more slowly closer to our planet. This warping of space-time is a fundamental concept of Einstein's theory of general relativity, and it's the very reason gravity exists in the first place. Imagine a stretched-out sheet, and you place a bowling ball in the middle. The sheet dips, and any marbles rolling by will be pulled into the dip. Our new super-Earth would be a cosmic bowling ball, creating an immense, profound dip in the fabric of space-time, pulling everything in its path toward it. This would make space travel not just difficult, but almost impossible. The escape velocity of a planet is the speed an object needs to be traveling at to break free from its gravitational pull. On our current Earth, it's about 11 kilometers per second. On our new super-Earth, it would be hundreds, if not thousands of kilometers per second. The energy required to launch a rocket and escape its pull would be astronomical, far beyond anything we could imagine today. The planet would be a cage, a gravitational prison. Nothing would be able to leave, and nothing would be able to reach it from the outside without being pulled into a fiery final descent. The dream of space exploration, of reaching for the stars, would be a distant, impossible fantasy for anyone trapped on this world. This terrifying reality offers a poignant reminder of our current state of existence. We live on a planet with just the right amount of gravity to both keep us tethered to our home and to allow us the freedom to reach for the stars. The cosmic ripple effect would not stop there. The sheer gravitational pull of our new planet could potentially change the flow of the Oort cloud, a vast theoretical cloud of icy objects at the very edge of our solar system. The delicate, slow orbits of these comets could be disturbed, sending a shower of them, hurtling toward the sun or even our new Earth. This wouldn't be a gentle rain. It would be a catastrophic biblical event, a constant threat of impact from the far reaches of our solar system. The balance of our cosmic home would be completely undone, replaced by a new, more chaotic and violent reality. Ultimately, the thought of a supersized Earth is a profound exercise in understanding the interconnectedness of our universe. A single change, a single variable altered, can ripple outwards and change everything. We see our solar system as a stable, predictable home. This thought experiment reveals its deep fragility, its dependence on a very specific set of conditions. It reminds us that our place in the universe is a lucky accident of immense, powerful, and balanced forces. And as we continue to drift into this new reality, we have to grapple with this central mystery. Are there other equally stable configurations of planets and stars in the universe? Or is our own solar system a rare and beautiful cosmic anomaly? The truth is, we are still so new to this understanding of the cosmos. So much of it remains a secret, a quiet whisper in the dark. The cosmic dance, disrupted and chaotic as it now is only the beginning. Our journey into this impossibly large world must now take us inward to its very heart. With a mass equal to the sun's, the crushing gravitational force we've already discussed wouldn't just stay on the surface, it would continue its relentless pressure all the way to the core. On our current Earth, the pressure at the center is immense, about 3.6 million times that of the atmospheric pressure at sea level. That pressure is enough to turn iron into a solid, albeit incredibly hot, inner core. But with a sun-sized Earth, the pressure at the core would reach astronomical levels far beyond anything we can currently replicate or even fully comprehend. Imagine squeezing something with the weight of hundreds of thousands of planets. The familiar rules of chemistry and physics begin to break down. The atoms themselves would be pushed closer and closer together, their electron shells, which usually keep them apart like tiny energetic shields, would begin to compress and overlap. This process is known as atomic compression, and it would fundamentally change the nature of matter itself. The core of this new Earth would no longer be a mix of molten iron and nickel. It would be something new, something exotic. It's possible that the pressure would be so great that the atoms would be stripped of their electrons, creating a plasma-like state of matter, even at unimaginable temperatures. The very building blocks of the universe would be crushed into a superdense soup, a state of matter only found in the hearts of stars and in our scientific particle accelerators for fleeting moments. The line between solid liquid and gas would blur into oblivion, replaced by a new, more mysterious state of existence. This immense pressure would also generate an incredible amount of heat. As the planet formed and compressed, all that gravitational potential energy would be converted into thermal energy. The core of our new Earth would be unimaginably hot, possibly hotter than the surface of the sun. This isn't just a simple increase in temperature. It's a fundamental change in the planet's internal engine. This vast, seething heart of our world would be a source of constant, intense energy, driving the planet's internal processes and creating a geothermal landscape on a scale we cannot even begin to imagine. The geology of this world would be defined by this unyielding inner heat and pressure, a constant battle between the forces of creation and destruction. This brings us to a fascinating and little-known scientific curiosity: the existence of superionic ice. On planets larger than Earth, with immense pressure, water can exist in a state where the oxygen atoms form a rigid crystal lattice, but the hydrogen ions are able to move freely like a liquid through the structure. It's a hybrid state of matter part solid part liquid. It's a strange ethereal form of ice that's both frozen and flowing. It's a hypothetical but very real possibility for the interior of our new, massive world. In this state, a substance we see as simple and familiar water becomes something alien and profound. It reminds us that the universe is full of secrets, and that the things we think we know, like ice, can become unrecognizable under a different set of physical laws. The very nature of a substance depends entirely on its environment. The sheer scale of this inner world, this churning heart of exotic matter, makes us think about our own planet's core. We've never been able to travel there, of course. Our understanding of it is a product of seismic waves of indirect measurements and clever deduction. We know it's a swirling dynamo of liquid metal that creates our protective magnetic field. But what would the core of our new super-Earth be like? Would it be a faster spinning dynamo, creating a magnetic field so powerful it could protect the planet from solar winds and cosmic radiation? Or would the pressure be so immense that it would slow the core's rotation to a halt, leaving the planet exposed and vulnerable? It's another one of those beautiful, unanswered questions in science. The truth is, our models of planetary interiors break down at these extreme scales. We can extrapolate, we can theorize, but we don't really know for sure. This thought experiment also leads us to a deeper philosophical question about scale. We are so used to our human scale, the size of our bodies, the height of our mountains, the depth of our oceans. But the universe operates on scales that defy our intuition, from the infinitesimal world of quantum mechanics to the incomprehensible size of galaxies. Our new massive Earth would force us to confront this reality. The difference between our normal Earth and this new one is not just a change in number, it's a change in kind. The laws of physics, while consistent, manifest in new and unexpected ways when the variables are stretched to their limits. This is a recurring theme in the history of science, the discovery of new physics at the extreme ends of the spectrum, whether it's at the speed of light or at the pressures of a planetary core. It's a humbling reminder that our cozy human-sized understanding of the world is just one small slice of a much larger and stranger reality. The journey into the heart of this giant world is a journey into the heart of scientific discovery itself. We are not just exploring a hypothetical planet, we are exploring the limits of our own understanding. With the immense pressure and exotic matter churning at the core of our super-Earth, it's time to turn our attention back to the surface. But not to the land which has already been pulverized, but to the oceans. The oceans of our current world are vast and powerful, a constant source of life and change. Their ebb and flow, the rhythmic rise and fall of the tides, are driven by the gentle gravitational pull of the moon, and to a lesser extent, the sun. On our new, impossibly large planet, this gentle rhythm would be replaced by a cataclysmic tidal symphony. First, let's discard the notion of a moon. As we discussed, our lunar companion would have been torn apart, but the sun's gravitational pull would still exist, and it would be working on a body with over 300,000 times the mass of our original Earth. The tidal forces generated by this interaction would be monumental. The water in the oceans, what little of it might still exist in a liquid state under the crushing atmospheric pressure, would be pulled into vast mountain-sized bulges on the side of the planet facing the sun and on the opposite side. This isn't just a tide of a few feet. This is a tide of hundreds, perhaps thousands of miles. The sheer volume of water being moved would be staggering, and the friction generated by this movement would create an immense amount of heat. Any land masses that somehow survived the initial crushing pressure would be submerged, then exposed, then submerged again in a relentless punishing cycle. It would be a world of perpetual planet-spanning tsunamis. This relentless tidal force would also have a profound effect on the planet's rotation. Our current Earth is in a slow gravitational dance with the moon that is gradually slowing our rotation and pushing the moon away. This is a scientific concept known as tidal locking, and it's why we always see the same side of the moon. A similar process would happen here, but on a scale so grand it defies imagination. The immense tidal bulge created by the sun's gravity would act like a brake slowing the planet's rotation over a relatively short period of time. Eventually, the planet would become tidally locked to the sun. This means one side of the planet would perpetually face the sun, while the other side would be locked in eternal darkness. The day and night cycle, a fundamental rhythm of life on Earth, would cease to exist. This would create a world of extreme, unimaginable contrasts. One side eternally baked by the sun's heat and ravaged by constant tides, the other side a frozen wasteland of perpetual night. It's a reminder that even the most fundamental aspects of our world, like the rising and setting of the sun, are a product of a delicate and fragile cosmic balance. The immense tidal forces would not be confined to the oceans. The solid crust of the planet itself would be stretched and compressed. This is known as solid body tides, and it's an effect we can measure on our current Earth, although it's a matter of inches. On our new super-Earth, the solid body tides would be a matter of miles. The very ground beneath your feet would be rising and falling, a constant, slow, and terrifying geological pulse. This constant stretching and compression would create unimaginable internal friction, generating even more heat within the planet's core and mantle. It's a feedback loop of destruction and change with gravity as the primary driver. This constant geological stress would create immense fault lines and trigger supervolcanoes on a scale that would make the eruption of Krakatoa seem like a firecracker. The very crust of the planet would be a canvas for gravity's raw power, constantly shifting and reshaping itself in a chaotic ballet of tectonic forces. This leads us to a strange, almost poetic truth about the universe. Gravity, the force that holds stars and galaxies together, is also a force of immense destruction. It is the creator and the destroyer, the artist and the vandal. In this new world, we see its destructive power laid bare. The once familiar landscape, the gentle rhythm of the tides, the constant spin of our day, all are unmade by a single terrifying increase in mass. This thought experiment is not just about the science of a new planet. It's about the philosophy of change, of what happens when a fundamental constant of our existence is altered. It makes us wonder, doesn't it, about the hidden forces that shape our reality and how close we always are to a different and far more dangerous existence. This tidal symphony, this constant geological upheaval, also introduces a little-known astronomical fact about resonance. When two or more celestial bodies exert a periodic gravitational influence on each other, they can enter a state of orbital resonance. This is what helps keep the rings of Saturn in their intricate patterns. On our new massive Earth, this resonance with the Sun could create strange and unpredictable orbital effects. The planet's orbit could become more eccentric, or it could be destabilized entirely, turning the dance of giants into a violent collision. The universe in its own silent way abhors a lack of balance, and a planet of this size would be a profound disruption to that balance. The final truth of this celestial ballet is that it is not a dance of perfect harmony, but a delicate truce between powerful and opposing forces. And in this new reality, that truce has been broken. With the planet now tidally locked and its surface a canvas for gravity's wrath, we must lift our gaze from the chaos below and consider the very sky above. On our current Earth, the atmosphere is a thin, fragile blanket. It's a clear, mostly transparent layer that allows the sunlight to pass through, paints our sky a gentle blue, and filters out the more harmful radiation. But on our new super-Earth, with a mass equal to the Sun, this atmosphere would be something entirely different. The crushing gravitational pull would have compressed it into a dense, heavy envelope, a sea of gas far thicker and more opaque than anything we can imagine. The simple act of light traveling through this atmosphere would be fundamentally altered. This leads us to a core scientific concept called atmospheric refraction. Refraction is the bending of light as it passes through different mediums. It's what makes a straw in a glass of water look broken. On our current Earth, the atmosphere bends light just enough to create beautiful phenomena like sunsets and rainbows. But on our new super-Earth, the immense density of the atmosphere would cause light to bend and scatter in a profound way. The sky would likely not be blue at all. Instead, it might be a perpetual hazy twilight, a swirling soup of refracted light. The sun might appear as a faint, diffuse glow in the sky rather than a brilliant, distinct orb. It's a world where the very light that gives us life is distorted and muted, a constant reminder of the crushing forces at play. This dense atmosphere would also have a profound effect on the planet's heat and weather. The atmosphere would be an incredibly effective insulator, trapping the heat from the sun on the sun-facing side and preventing it from radiating into space. This would create a runaway greenhouse effect, a blistering Venus-like inferno, where temperatures would soar to unimaginable heights. On the dark side of the planet, however, the lack of sunlight would mean temperatures would plummet to the coldest reaches of absolute zero. The air would likely freeze solid, falling as snow of nitrogen and oxygen on a perpetually frozen landscape. The boundary between these two extremes would be a place of unimaginable violent weather. The air would move from the hot bright side to the cold dark side in a constant furious rush, creating winds of incredible speed and power. Far beyond any hurricane or storm we have ever witnessed, it would be a world of perpetual planet-spanning winds, a world where the very air is a weapon. The light from distant stars would also be affected by this thick, refracting atmosphere. On our current Earth, we can see the universe in its majesty, the constellations and galaxies appearing as pinpricks of light in a black sky. But on our new super-Earth, the light from these stars would be bent and distorted, their positions in the sky shifted by the atmosphere's immense refractive power. The constellations we know and love would be unrecognizable, their stars appearing in new, strange patterns. The very act of looking up at the sky would become a journey into a funhouse mirror of the cosmos. This makes us think about a little-known scientific fact. The phenomenon of celestial refraction is something astronomers must account for when they observe objects low on the horizon. On our new super-Earth, this effect would be magnified to an absurd degree, turning the entire sky into a lens. This distortion of light and atmosphere introduces a fascinating philosophical question. We perceive the universe through the lens of our senses, and those senses are shaped by the physics of our world. If we were to live in a world where light itself is distorted, would our perception of reality be fundamentally different? Would our understanding of the universe be warped by the very air we breathe? It's a deep and unsettling question that reminds us that our reality is a very local and specific thing. The truth is, we don't really know how our minds would adapt to such a profound change in our sensory input. It's a mystery that lies at the intersection of physics and consciousness. This journey into the atmosphere of a super-Earth also reminds us of the delicate and vital role our own atmosphere plays. It's not just the air we breathe. It's a shield, a temperature regulator, and a window to the cosmos. Its density is perfect. Its composition is a fragile blend of gases, and its thickness is just right. To change any one of these variables is to change everything. Our current atmosphere is a masterpiece of balance, and to see what a planetary atmosphere could become under a different set of rules is to appreciate the quiet genius of our own. It's a gentle whisper in the night, a reminder to be grateful for the subtle forces that make our world a home. Having explored the crushing physics of this new world, we now turn to a more tender and perhaps more tragic question. What of life? On our current Earth, life is a delicate and wondrous tapestry woven from a perfect blend of elements and energy. We have evolved over billions of years to thrive in this very specific gravitational environment. Our bodies, with their bones, muscles, and circulatory systems, are perfectly engineered to resist the familiar pull of a single G. But on a planet with a mass equal to the Sun, where gravity is over 300,000 times stronger, the very concept of life as we know it would be impossible. The immediate effect on any existing life form would be catastrophic. Our bones would shatter, our muscles would tear, and our circulatory systems would fail instantly. Our hearts, powerful as they are, would be unable to pump blood against such immense gravity. We would be flattened, compressed, and utterly destroyed. This is a scientific principle known as the square cube law, and it's a fundamental limitation of scale. As an object gets bigger, its volume increases much faster than its surface area. For a biological organism, this means that as you get larger, your weight increases much faster than the strength of your bones and muscles. A supersized Earth would simply take this law to its most brutal final conclusion. Life as we know it is a product of a very specific scale, and to change that scale is to erase the very possibility of that life. But let's allow our minds to wander for a moment, to dream a bit, and ask a more speculative question. What if life could evolve on such a world? What kind of life could possibly survive and even thrive in such a high-gravity environment? The answer is that it would have to be completely alien to our understanding. Life forms would likely be incredibly small, perhaps no bigger than a few inches, so that their own mass would not crush them. They would be low to the ground, perhaps with no limbs or a vast number of small strong ones to distribute their weight. They would have to be incredibly dense, their internal structures a kind of biological composite, able to withstand the pressure. We could even imagine life forms that don't rely on skeletal structures at all, but rather on some form of hydrostatic pressure, a bit like a jellyfish, to maintain their shape. The very chemistry of life would be different. On Earth, our biology is a chemistry of carbon, oxygen, and hydrogen, all reacting in a specific way under our atmospheric pressure. On our new super-Earth, the immense pressure and heat would likely favor a completely different type of chemistry, perhaps based on other elements with different bonds and reactions. This leads us to the concept of panspermia, a hypothesis that life exists throughout the universe and is distributed by meteoroids, asteroids, and planetoids. Could life from our new Earth, if it ever formed, be so different that it couldn't even be called life by our standards? Could it be a completely new branch of cosmic existence a testament to the universe's infinite capacity for novelty. The truth is, we don't know if life is a singular carbon-based phenomenon, or if it can take on a million different forms. It's one of the great mysteries that still haunts the halls of biology and astrobiology. This extreme thought experiment forces us to confront our own biases about life. We assume that life must be carbon-based, water-dependent, and require a specific range of temperatures. But what if life is more resilient, more creative than we can imagine? What if there are countless different chemistries of life out there, each one a unique answer to the specific physics of its own world? Our new super-Earth, with its crushing gravity and exotic pressure, could be a fertile ground for a kind of life that would find our world and our kind of existence to be a fragile and impossible dream. It's a humbling thought, a reminder that our own story is just one of an infinite number of possible stories in the cosmic library. And in the end, the biggest mystery isn't what life could look like on such a world, but whether we would even be able to recognize it as life at all. The very concept of life might be as local and specific as the gravity we feel beneath our feet. Having considered the tragic fate of life and the violent symphony of the tides, we must now delve deeper beneath the surface and into the very skin of this new, massive world. The geology of a sun-sized Earth would be a spectacle of both immense power and unimaginable stillness. Our current planet is a world of constant motion. The lithosphere, the rigid outer shell of the planet, is broken into a series of tectonic plates that float on a churning semi-molten mantle. This constant motion gives us earthquakes, volcanoes, and the slow, majestic dance of continents. But what happens when you increase the mass and gravity by a factor of 3 per 3,000? The immense pressure would have a profound effect on the planet's internal dynamics. The magma in the mantle, a thick viscous fluid on our Earth, would be compressed to an almost solid state. This leads us to a strange, almost contradictory idea: mantle stagnation. On super-Earths, scientists theorize that the immense gravity and pressure can make the mantle so thick and viscous that the convection currents that drive plate tectonics on our planet would either slow to a crawl or stop entirely. The tectonic plates would become locked in place, frozen in a geological slumber. This would be a world of immense crushing stillness, a world without the geological heartbeat of plate tectonics. The mountains would no longer rise, the continents would no longer drift, and the very face of the planet would be set in a permanent, terrifying frown. However, there's another side to this story, a more chaotic and violent possibility. The immense heat generated by the core and the constant internal friction from the solid body tides could create a different scenario. Instead of stagnation, we could have a geology of cataclysm. The pressure building up beneath the locked crust would be unimaginable, and when it finally found a weak point, the eruption would be on a scale that defies our comprehension. We're not talking about a single volcano like Mount Vesuvius. We're talking about planet-spanning fissure eruptions, a supervolcanism that would belch out enough ash and gas to completely blot out the already dimmed sun. This leads us to a little-known astronomical fact: the existence of lava planets, exoplanets, so close to their stars that they have oceans of molten rock and a constant hail of fiery rain. Our new Earth might be a terrestrial version of this, a world where the surface is a constant terrifying dance between crushing stillness and catastrophic fire. This duality, this tension between stillness and chaos, is a profound philosophical question. Is the universe a place of subtle, constant change, or is it a place of long periods of quiescence punctuated by moments of immense violence? Our own Earth, with its gentle, persistent tectonic plate movements, seems to favor the former. But our new super-Earth, with its exaggerated physics, suggests the latter. It makes us wonder if our perception of a slowly changing, stable world is just a product of our own specific lucky circumstances. What if most planets in the universe are locked in a geological slumber, only to be awakened by a cosmic cataclysm? The truth is, we don't really know for sure. It's a mystery that lies at the heart of planetary science, a question that reminds us that our own world is not just a home, but an artifact of a very specific and possibly very rare set of cosmic rules. This thought experiment, as it delves into the core of our planet, reminds us that the forces that shape our world are not just on the surface. They are deep within, silent and powerful, the heartbeat of our home. And to change that heartbeat is to change everything. We are not just living on a planet. We are living on a dynamic, living entity. And the health and stability of that entity depend on a delicate balance of forces, a balance that in this new world has been shattered. The stillness of a stagnant mantle and the chaos of cataclysmic volcanism are both consequences of the immense pressure at the heart of our super-Earth. But this pressure cooker core isn't just a geological force. It's also a source of energy, and its immense activity would have a profound effect on another vital aspect of our planetary existence, its magnetic field. Our current Earth's magnetic field is a powerful protective shield, an invisible force field that deflects the sun's harmful charged particles, the solar wind, and keeps our atmosphere from being stripped away. This field is generated by a process known as the planetary dynamo. The planetary dynamo is a complex, beautiful thing. It's a dance of swirling molten iron in our outer core, a fluid conductor moving at a great speed driven by heat and the planet's rotation. This motion generates electric currents, and those currents in turn create a magnetic field that extends far out into space. It's a self-sustaining system, a kind of cosmic perpetual motion machine that keeps our planet safe. But what happens to this dynamo on a planet with the mass of the sun? The immense gravitational pressure we've been discussing would generate an incredible amount of heat, making the core's molten state even more energetic. This increased energy could create an even more powerful, more stable dynamo, a magnetic field so strong it would be an impenetrable fortress against cosmic radiation. On such a world, the sky might be free of the shimmering auroras we see at the poles, as the magnetic field would be so strong that the solar wind would be deflected far from the atmosphere, unable to interact with the gases to create that beautiful light show. However, there's a more nuanced side to this. Remember how we discussed the possibility of the mantle becoming stagnant? This stillness could also affect the core's rotation and the flow of the molten material. It's possible that the immense pressure could actually slow the dynamo or even create a chaotic multipole magnetic field. A magnetic field that is not a simple north and south pole, but a tangled web of many poles shifting and changing. This would be a less effective shield, a more chaotic and unpredictable protector. This leads us to a little-known fact about planetary magnetism. Some moons like Ganymede, a moon of Jupiter, have their own magnetic fields, and some planets, like Mars, have lost theirs. The existence of a planetary dynamo is not a given. It is a delicate balance of heat rotation and conductive material. On our new super-Earth, that balance would be pushed to its absolute limit, and the outcome is a fascinating mystery. We don't really know for sure if a larger dynamo would be more stable or more chaotic. It's one of those beautiful unanswered questions in geophysics, a question that reminds us that the forces that protect us are not eternal and unchanging, but a product of a very specific set of circumstances. This brings us to a more philosophical point. A powerful magnetic field is in a way the planet's breath, its vital force. It is what allows our atmosphere to remain, our water to stay, and our life to thrive. Without it, our planet would be a dead barren rock stripped bare by the sun's fury. In this new world, we see the potential for a dynamo of unimaginable power, a silent, powerful guardian against the chaos of space. But we also see the potential for that power to be chaotic and unstable. It makes us wonder, doesn't it, about the nature of power itself. Is more power always better? Or is there an optimal, gentle balance that allows for the greatest good? The quiet truth is that our own magnetic field, with its gentle, persistent rhythm, is the perfect example of a powerful force in perfect balance. It is a subtle whisper that allows life to flourish And it is a reminder that the most profound forces in the universe are not always the most violent ones. With the planet's internal engine now a mystery of immense pressure and a potentially chaotic dynamo, we must turn our attention to the final frontier, the very fabric of space-time itself. On our current Earth, we live in a reality where time is a constant, a steady flow from past to future. We measure it with clocks, and we experience it as a universal shared rhythm. But on a planet with a mass equal to the Sun, this fundamental truth would be bent and twisted, revealing a more nuanced and far stranger reality. This leads us to a central concept from Einstein's theory of general relativity, gravitational time dilation. It's the idea that gravity, the force that we experience as weight, also affects the passage of time. The stronger the gravitational field, the slower time flows. The effect is minuscule on our current Earth, so small that we need atomic clocks to measure it. For an astronaut on the International Space Station, time moves a tiny fraction faster than it does for us on the surface. But on a super-Earth with the mass of the Sun, the gravitational field would be so immense that the effect would be profound and undeniable. A minute on the surface of this world would be longer than a minute for an observer far out in space, or even for an observer on a less massive planet. This would create a bizarre, almost surreal reality. Imagine two people, one standing on the surface of this new world and another in a spaceship hovering 1,000 miles above. For the person on the spaceship, a simple 1-minute conversation with the person below would last for 1.5 minutes. The person on the surface would experience it as a minute, but the passage of time for them would be slower. This isn't a trick of perception. It's a fundamental reality of physics. Their watches, their biological clocks, and even the speed of their thoughts would be moving at a different rate. The very concept of a shared now would cease to exist. The idea that we are all moving through time together would be a pleasant fiction replaced by a reality where time is as local as the weather. This leads us to a fascinating and little-known scientific paradox, the twin paradox. In this thought experiment, one twin travels at near the speed of light, while the other stays on Earth. When the traveling twin returns, they are younger. Gravitational time dilation is a cousin to this paradox, but instead of speed, the variable is gravity. On our new super-Earth, the twin on the surface would age slower than their twin in a spaceship far away. The paradox is not a paradox at all, but a beautiful and mind-bending truth of our universe. Time is not a river that flows at a constant speed for everyone. It is a landscape, and our position in that landscape determines the speed of our journey. This philosophical journey into the nature of time itself forces us to confront our own biases about reality. We assume that time is a universal constant, a steady drumbeat that governs all existence. But this thought experiment and the truths of general relativity show us that time is a flexible, dynamic thing, a part of the very fabric of the universe that can be stretched and compressed by gravity. It makes us wonder, doesn't it? What other fundamental truths about our reality are not truths at all, but simply a product of our own limited perspective? The truth is, we are still so new to this understanding of the cosmos. So much of it remains a secret, a quiet whisper in the dark. The immense gravitational field of our new world, a cosmic thumbprint pressed into the very fabric of space-time, would have profound effects, not only on the passage of time, but on our relationship with the universe beyond. On our current Earth, we are a part of a vast, star-filled cosmos. We can look up on a clear night and see the Milky Way, a faint, ethereal band of light that is our galactic home. But on our super-Earth, this connection would be muted, our cosmic window, smeared and distorted by the immense gravity. This leads us to a fundamental and beautiful idea in cosmology. The universe is not just out there. It is a thing we perceive through our local physics. On our new super-Earth, the immense gravity would not only bend light from distant stars, a phenomenon known as gravitational lensing, but it would also make the act of simply looking up a different experience. The light from a distant star, a pinprick of light from a far-off sun would have to climb out of our new planet's deep gravitational well. In doing so, it would lose energy, a process known as gravitational redshift. This means that a star that might appear blue to us on our current Earth could appear red or even infrared on our new world, its light stretched by the planet's immense gravity. The night sky, instead of being a tapestry of brilliant diverse colors, would be a uniform reddish blur. The colors of the universe muted and shifted by our own planet's immense pull. This brings us to a fascinating and little-known scientific fact. The discovery of gravitational redshift was one of the first experimental proofs of Einstein's general relativity. We've seen it in the light from stars and galaxies, and we can even measure a tiny redshift in light from the sun. But on our super-Earth, this effect would be magnified to an absurd degree, making the night sky a permanent testament to the power of gravity. It's a humbling thought, isn't it, that our very perception of the cosmos, the colors and positions of the stars, is a local phenomenon, a product of our planet's specific gravitational field. This immense gravity would also make the act of leaving the planet a near impossibility. We spoke briefly about escape velocity earlier, but let's consider it more deeply now. On our current Earth, we have achieved a kind of quiet mastery over gravity. We can send rockets into space, we can send probes to other planets, and we can dream of traveling to the stars. But on our new super-Earth, the escape velocity would be so high, the energy required so immense, that the dream of space travel would likely be abandoned. The planet would be a gravitational prison, a world of unimaginable power that would be forever cut off from the rest of the cosmos. No one would be able to leave, and no one from the outside would be able to get in without being pulled into a fiery final descent. The planet would be a cosmic island, a lonely, powerful monarch in a solar system of subjects. This isolation leads us to a philosophical question about our place in the universe. On our current Earth, we are part of a cosmic community. We receive signals from space, we watch distant galaxies collide, and we dream of a future among the stars. But on a super-Earth, we would be alone, our connection to the rest of the universe severed. Would this isolation foster a greater sense of community and introspection, or would it lead to a kind of cosmic despair? The truth is, we don't know. It's one of those beautiful, unanswerable questions that reminds us that our own place in the universe is a very specific and possibly very lucky set of circumstances. It's a reminder that our current world, with its gentle gravity and its clear window to the stars, is a gift, a perfect balance of forces that allows us to not only live, but to dream of things beyond ourselves. The profound isolation of our new super-Earth, a cosmic island adrift in a sea of space-time, would be further amplified by the simple yet fundamental reality of its size. We've talked about the internal chaos and the external gravitational pull, but let's consider the simplest effect of all, the shadow. On our current Earth, the sun's light bathes one side of the planet in warmth and light, while the other side is cast into shadow, the familiar cycle of day and night. But on a planet with a diameter over 100 times larger than our own, the shadow it casts would be a colossal cosmic void. This leads us to a fascinating and little-known concept in astronomy called syzygy, which is when 3 or more celestial bodies are in a gravitational alignment. Eclipses are a form of syzygy. On our new super-Earth, its colossal size would mean that during an alignment with the sun, it would cast an immense shadow that could potentially engulf multiple planets and moons. The sheer size of this shadow would be a cosmic spectacle, a silent march of darkness across the solar system. Imagine being on Mars or Jupiter and watching as a colossal planet-sized shadow slowly creeps across the sky, blotting out the sun and plunging your world into a temporary yet terrifying darkness. This wouldn't be a delicate, graceful eclipse. It would be a planetary blackout, a reminder of the immense power and scale of our new world. The shadow itself, this lack of light, would also have a profound effect on the planet's climate. Remember how we discussed the tidally locked nature of this world? The sun-facing side would be a blistering inferno, and the dark side would be a frozen wasteland. The immense size of the planet means the transition zone between these two extremes, the so-called Terminator line, would be a vast planet-spanning band of perpetual twilight. This would be a place of unimaginable furious weather, where the constant flow of air from the hot side to the cold side would create winds of incredible speed and power. The shadow isn't just a lack of light. It's a fundamental part of the planet's climate and weather system, a silent cold hand that shapes the atmosphere and the temperature. This planetary shadow also forces us to confront a deeper, more philosophical question about our place in the cosmic hierarchy. On our current Earth, we are a small part of a vast star-filled universe. Our planet is a speck of dust, and our presence is a fleeting, insignificant moment in cosmic time. But on a super-Earth with the mass of the sun, our world would be a dominant, powerful presence, a force to be reckoned with. The shadow it casts would be a testament to its power, a silent, visible reminder to the rest of the solar system of its sheer scale. It's a humbling thought, isn't it? To consider a world where our home isn't a fragile speck of dust, but a colossal, powerful, and terrifying presence. The truth is, this shadow is a beautiful metaphor for the unseen forces that shape our reality. Just as a physical shadow is an absence of light, a metaphorical shadow is an absence of understanding. We are often so focused on the light, on what we can see and what we can measure, that we forget about the profound unseen forces that shape our world. The gravitational field, the planetary dynamo, the silent march of geological time. These are the shadows that define our reality, and it is only by exploring them that we can truly understand our place in the cosmos. Our journey through this colossal world has been a scientific one, exploring the profound changes in gravity, geology, and light. But as we stand on this immense, tidally locked world, with its perpetual twilight and crushing atmosphere, we must turn our attention to the human, or perhaps more accurately, the philosophical and psychological cost of such a transformation. The loss of the familiar, the erasure of everything we have come to know, would be a profound and deeply unsettling experience. Imagine waking up to a world where the very ground beneath your feet feels impossibly heavy, where the sky is a permanent hazy smear of red, and where the rhythmic certainty of day and night is a forgotten memory. The landmarks we hold dear, the towering peaks of Everest, the deep canyons of the sea, the gentle curves of our continents would be flattened and erased by gravity's unyielding hand. This loss of physical landmarks would also be a loss of emotional and cultural landmarks. Our history, our myths, our poetry are all tied to the specific geography of our world. The stories of Odysseus on the wine-dark sea, the legends of dragons in the mountains, the quiet comfort of a familiar landscape, all of it would be rendered meaningless. We would be a people without a home, a species without a past, adrift in a new alien world. This psychological burden, this sense of cosmic loneliness would be immense. The loss of the familiar night sky, the gentle tapestry of the stars would be a profound and deeply unsettling experience. For millennia, humanity has looked to the stars for guidance, for inspiration, and for a sense of our place in the universe. On our new super-Earth, with its distorted hazy sky, that cosmic connection would be severed. We would be a people living under a veil, unable to see our cosmic neighbors, unable to feel the gentle pull of the universe. This isolation would force us to look inward, to confront the profound truth that we are utterly alone, a single solitary species on a colossal, powerful, and terrifying world. This leads us to a little-known psychological concept known as solastalgia. It's a term coined by philosopher Glenn Albrecht, and it describes the feeling of distress or loss that people feel when their home environment undergoes unwelcome change. It's the homesickness you feel when you are still at home. On our new super-Earth, everyone would be experiencing solastalgia on a planetary scale. The home we once knew, the world we once loved, would be gone, replaced by an alien landscape. The pain of that loss would be a constant low-level hum in the background of all existence, a ghost of the past haunting the present. The very concept of scale would also be a psychological burden. Our minds are built to understand and navigate a world of a certain size. The distances we travel, the heights we climb, the depths we explore. All of these are on a human scale, but on a super-Earth with the mass of the Sun, all of these concepts would become meaningless. A simple walk would be an impossible physical feat, and a journey from one point to another would take a lifetime. The sheer scale of the world would make it feel infinite and unknowable, a place that no one could ever truly explore or understand. This feeling of being utterly small and insignificant in the face of such a colossal world would be a profound and deeply unsettling experience. It would be a world that constantly reminds us of our own powerlessness, a world that is always larger than us, more powerful than us, and more ancient than us. This journey into the psychological and philosophical impact of our new world is a reminder that science is not just about numbers and equations. It is about understanding our place in the universe, our connection to the world around us, and the profound emotional cost of change. We are not just biological machines. We are beings of memory, emotion, and connection. And to lose that connection, to lose the world that gave us our stories and our dreams, is to lose a part of ourselves. The truth is, a world with the mass of the Sun would be an interesting scientific specimen, but it would be a tragic and lonely home. Having explored the internal, external, and psychological consequences of our colossal world, we must now turn our attention to the star at the center of it all, our Sun. The Sun is a constant presence in our lives, a source of light and warmth, and a silent, powerful partner in the cosmic dance of our solar system. But what happens when its dance partner, our little Earth, swells to its own size? The Sun would no longer be the sole monarch of its realm. It would be in a gravitational relationship with a new, equally powerful companion. This new equal partnership would fundamentally alter the Sun's existence. Remember how we talked about the tidal forces on our new super-Earth? Those same forces would be at play on the Sun, but on an even grander scale. The Sun's plasma, its superheated, swirling ocean of charged particles, would be pulled and stretched by our planet's immense gravity. This could create colossal, unprecedented solar flares, far larger and more frequent than anything we see today. The Sun's very surface would be a canvas for our new Earth's gravitational art, a constant dance of flares, sunspots, and coronal mass ejections. This new powerful interaction could also affect the Sun's internal processes. The Sun is a delicate balance of forces, the outward pressure from nuclear fusion, perfectly counteracted by its own inward gravitational pull. Our new Earth's immense gravity, pulling on the Sun from a relatively close distance, could potentially disrupt this balance. It's a fascinating and as yet unanswered question in astrophysics. Could a large, close-orbiting planet affect the rate of a star's nuclear fusion? Could it shorten the Sun's lifespan or even accelerate its death? We don't really know for sure. The truth is, the interaction of two such massive, equal-mass objects at a planetary distance is a scenario that has never been observed. It's one of those beautiful, unanswered questions that reminds us that science is a journey into the unknown. This brings us to a little-known fact in astronomy: the existence of binary star systems. In these systems, two stars orbit a common center of gravity, a point in space known as the barycenter. Our Sun and new super-Earth would, in effect, become a kind of bizarre binary system, a star and a planet of equal mass, locked in a perpetual silent dance. The barycenter of this system would not be inside the Sun, but somewhere in the space between the two bodies. The Sun, our quiet, gentle monarch, would find itself no longer at the center of our solar system's universe, but rather a partner in a gravitational waltz. This is a profound and unsettling thought. The idea that our Sun, the very source of our light and life, could be a subject of another planet's power. is a humbling reminder of the chaotic and unpredictable nature of the cosmos. This shift in cosmic power leads us to a more philosophical truth. Nothing is truly permanent. The sun, which has been a stable, unchanging presence in our sky for billions of years, is just a temporary phase in the universe's long story. And the interactions it has with its planets can change its course, its lifespan, and its very nature. Our thought experiment in this way is a kind of cosmic mirror reflecting back to us the profound fragility and impermanence of all things. The sun's gentle fury, its constant output of energy and light, is not an eternal gift. It is a temporary act of creation, and it is a gift that can be altered and even taken away. We have journeyed far from the first crushing moment of expansion to the final quiet dance of giants in our solar system. Now, as our exploration nears its end, let us pause and reflect. Let us revisit the scientific concepts we have explored, not with the dry logic of a textbook, but with the gentle poetic lens of memory. We will weave them into a final narrative about the planet's long silent journey through time. Remember the immense gravitational pull, a force so strong it compressed the very atoms of our world. That was the opening stanza of our story, a moment of cataclysmic creation. This gravity, this silent artist, sculpted a world of unimaginable pressure and heat, a place where matter itself became a new exotic thing. It was a world of compressed atoms and supersonic ice, a heart of fire and frozen chaos. This was the core of our new world, a testament to gravity's power. Remember the moon, our constant companion for billions of years, torn apart and transformed into a ring of fiery debris. That was the next tragic chapter in our tale, a moment of cosmic violence that reminded us of the profound fragility of the celestial ballet we have come to know. The tidal symphony, the relentless tug of the sun, turned our oceans into a force of destruction and our solid land into a pulsing, breathing thing. This was a world of perpetual tsunamis and solid body tides, a world where the very ground was alive with the immense power of gravity. And what of the atmosphere, that thin veil that once gave us a blue sky and a breathable world? It became a dense, suffocating blanket, a refracting lens that distorted the light from the sun and stars. Our view of the cosmos was forever changed, our connection to the universe muted and warped by our own planet's power. The day and night cycle, a fundamental rhythm of our existence, was replaced by a tidally locked world of eternal twilight and frozen night. This was a world of relentless winds and planetary shadows, a world where the very sky was a canvas for gravity's art. We also delved into the heart of the planet, the planetary dynamo that creates our magnetic field. We imagined a dynamo of immense power, a chaotic multipole field, a silent, unpredictable guardian of a world that would otherwise be stripped bare by the sun's fury. We considered the fate of life itself a tragedy of scale, a reminder that the forms of life we know are a delicate and specific product of our own gravity. We imagined new life, a theoretical, dense, and alien form of existence that could survive in such an extreme world, a testament to the universe's endless capacity for novelty. And we mused on time itself, on the profound and unsettling reality of gravitational time dilation. We learned that time is not a constant, but a flexible, dynamic thing, stretched and compressed by gravity. On our new world, a minute would be longer than a minute a day, a different length for everyone, a local and personal experience. It was a journey into the heart of time itself, a reminder that our perception of reality is a very local and specific thing. Finally, we reflected on the profound and lonely silence of a world without a connection to the stars. The immense gravitational redshift would mute the colors of the cosmos, and the vast escape velocity would make space travel an impossible dream. This was a world of cosmic isolation, a planet with no window to the universe beyond. It was a reminder that our current world, with its clear window to the stars, is a gift, a perfect balance of forces that allows us to not only live, but to dream of things beyond ourselves. Our journey has been a long one. a quiet, meditative exploration of a world that could have been. It is a journey that reveals a profound truth about our own world. We live on a planet of perfect balance, a delicate masterpiece of forces that allows for life, for science, for art, and for dreams. The gravity is just right, the atmosphere is just right, and the cosmic dance with the sun and moon is a graceful, gentle waltz. The chaos and violence of our hypothetical super-Earth are a reflection, a cosmic mirror that shows us just how lucky we are. And as we prepare to take our final step into this world, let us hold on to that truth, that quiet, gentle appreciation for the world we call home. Our journey, a quiet meditation on a world that is and a world that could be, now approaches its final, gentle conclusion. We have explored a world of crushing gravity and exotic matter, a place where the familiar rules of physics were stretched to their absolute limits. We saw the chaos of the celestial dance, the tidal fury of a new immense partner, and the profound loneliness of a world cut off from the stars. We reflected on the psychological cost of such a change, the loss of landmarks, and the erasure of memory. We have, in essence, spent a long and quiet time in a world that is a mirror reflecting back to us the profound and often unseen forces that shape our own reality. Now, as our journey nears its end, let us imagine the ultimate fate of this colossal Earth. A star and a planet of equal mass, locked in a perpetual dance. What happens to such a system over the long silent march of time? This leads us to a beautiful and terrifying question. Is this a stable existence, or is it a prelude to a new cosmic catastrophe? The immense gravitational forces, the constant tidal pull on both the Sun and our new Earth, could eventually cause a slow, inexorable decay of the system's orbit. The two bodies could spiral inward closer and closer until a final cataclysmic collision. This would not be a simple impact. It would be the death of two worlds, a final brilliant flash of light that would be visible across the entire galaxy. It would be a moment of cosmic violence, a final brilliant testament to the power of gravity. However, there is a more subtle and perhaps more poetic possibility. The immense gravitational stresses could also cause the two bodies to become tidally locked to each other, a process similar to the Earth and Moon, but on a scale so grand it defies imagination. The Sun and our new Earth would become a kind of cosmic double planet, each perpetually facing the other. They would be a pair of silent locked partners in a never-ending dance, their existence a testament to the power of gravity, to both destroy and to bind. This would be a stable yet profoundly alien existence. A world with a constant fiery companion in the sky, and a sun with a constant silent partner in its view. It would be a world of immense quiet power, a final state of being for a system that began in such chaos. This brings us to a little-known astronomical fact about stellar evolution. We know that stars like our sun go through a life cycle. They are born, they burn for billions of years, and they eventually die either in a quiet, beautiful puff of gas or in a violent, final supernova. Our new super-Earth, with its immense gravity, could profoundly affect the sun's life cycle. It could shorten its life, or it could cause it to burn out in a more violent, more spectacular way. The presence of a new, equally powerful partner could rewrite the rules of a star's death, turning a quiet whisper into a final, thunderous roar. The truth is, the death of a star is a beautiful and mysterious thing, and we don't really know for sure what happens when its final chapter is influenced by a partner of equal power. It's one of those beautiful, unanswered questions in astrophysics, a final quiet secret in the dark. This final thought, this meditation on the end of a world, is a reminder of the transient nature of all things. Our sun, our solar system, our very existence, all of it, is a temporary, fleeting moment in the grand silent march of cosmic time. And our journey in its own small way has been a beautiful and gentle journey into the heart of that truth. We have explored the power of gravity, the fragility of life, and the vast, beautiful, and terrifying unknown that lies at the heart of all things. And so our journey ends. We have sailed through a sea of unimaginable gravity, explored the hearts of planets and stars, and pondered the very nature of time itself. We have, for a little while, left our world behind and returned with a new sense of wonder, a quiet appreciation for the gentle, perfect balance of the world we call home. The colossal tidal forces, the distorted light, the immense gravitational pull, all of it fades now like a dream at dawn, a whisper in the quiet morning air. Let the memory of that powerful silent world gently brush past you like a soft breeze and allow your thoughts to drift back to this moment, to this quiet place, to the familiar gentle gravity that holds you to your bed. I'd like to gently ask one last time, where is the place you're staying now, the time in that place at this very moment? How is it flowing? Feel the quiet hum of your own world, the steady beat of its rhythm, the gentle pull that holds you safe, and as you close your eyes, know that you are a part of a beautiful, balanced, and miraculous cosmos. Sleep well, my companion, wherever and whenever you are. Sweet dreams.